Okay, are there any questions? If there's no questions, oops, we will get started. Oh, I gotta get my headphone on. Let me remind you guys to work on your unknown notes and get the unknown project started. Some of you have started, but the majority of you have not started. And like I said, this is not something you can just sit and wait at. All right, let me share my screen here. All right, can somebody confirm that you're seeing my screen?
Yes.
Thank you. And can somebody confirm that I'm recording this? I don't even see the button today. Oh, there. There it is. Never mind, I see it. Last time or one of the times earlier, I wasn't recording. All right, let me see if I can find where I was. Come on. So let me show you what we're doing today. We're working on Chapter 14, Principles of Disease. We probably won't finish the chapter today, but I do have time in the schedule for working on it on Thursday. We will have a quiz this week. This will be the last quiz. It will cover only Chapter 8 in the lecture and Lab 9 for the lab. So this will actually be a quiz that will cover less material than most of the other quizzes. And there is no lab at all this week. You're supposed to be working on your unknown project. I will be logging in from 6:30 to 6:45. If there are questions, please log in between 6:30 and 6:45. Once I'm done with the questions, or at 6:45, I'll be logging off. Any questions about any of this? Okay, if not, we had discussed this slide, classifying infectious diseases, and I did state that I tend to use symptom and signs together, and most of the time I'll just say symptom and sign. But they do have strict definitions in the textbook, and you should know the strict definitions. But understand, when you get into the clinic, especially patients, but I think clinicians too, will use the terms interchangeably. So let's talk about how we can classify infectious diseases. You can have communicable diseases. Those are a disease that is spread from one host to another. And in this class, we are concentrating on communicable diseases because most infectious diseases are communicable, because that's why they're called infectious. And communicable diseases tend to be caused by a microbe. There are also contagious diseases, and these are a disease that's easily spread from one host to another, or from one person to another. All contagious diseases are communicable, but not all communicable diseases are contagious. For example, measles and chickenpox are communicable diseases, but they're also contagious. A good example of a contagious disease would be something like the cold and the flu. It spreads very easily. But so do measles and chickenpox. TB, on the other hand, is a communicable disease, but it is not contagious because it doesn't easily spread from one host to another. Another good example of a communicable disease which is not contagious is leprosy. You have to have long-term exposure to the agent that causes leprosy before you'll get the disease. There are also non-communicable diseases, and these diseases do not spread from one host to another. Examples of non-communicable diseases include tetanus and botulism, which they are caused by a microbe, although the bacteria or microbe do not directly cause it. It's the toxin that causes these two diseases. We can also talk about the occurrence of a disease. To understand the full scope of a disease, we need to talk about its occurrence. By occurrence, we are talking about old and new cases. So when we're talking about the incidence of a disease, that's the fraction of a population that contracts a disease during a specific time. And we're talking about new cases only. Okay? And I meant to look up what the heck the new cases of COVID-19 were, because I don't know. And of course it changes with each day. But I think you know what I'm talking about. Prevalence, on the other hand, is a fraction of the population having a specific disease during a given time. So that would be the prevalence, both the old and the new cases. For example, in AIDS in 2007, the incidence for the year in the United States was 56,300 new cases in all of the year. But the prevalence of AIDS in 2007 was 1,185,000, many more cases because some people had gotten it before 2007. Now for COVID-19 in the United States, the prevalence is 33,274,769 confirmed cases, and we'll just say over 33 million cases as of today, May 25th. This is slightly over 10% of the population of the United States have had confirmed cases of COVID-19. And there's at least another 10% of the population in the United States that have had COVID-19, but they have not been confirmed. Remember that, especially among young people, and we'll talk a little bit about this later, but COVID-19 can infect young people, and they will be asymptomatic. They'll have no signs or symptoms, so they don't know that they have been infected. And that is most of you people because you're young, but this is also true of teenagers and children. Talking about the occurrence of disease, there's a couple of terms. A sporadic disease is a disease that occurs only occasionally in a population, like typhoid fever in the USA is a sporadic disease. It happens only occasionally. An endemic disease is a disease that constantly is present in the population. In the United States, the common cold is endemic, or you could say malaria is endemic to the tropics in the world. An epidemic disease is a disease acquired by many hosts in a given region over a short period of time. Like every so often, I think it's about every once in 10 years, we have an epidemic of influenza start, and this will quickly become pandemic, where it becomes worldwide. At the moment, we have a pandemic disease of COVID-19 in the world, where the cases are much higher than normal. And of course, with COVID-19, before 2019, there were no cases of it. But it started as an epidemic in China, and it quickly spread worldwide and became pandemic. Any question about any of that? All right, I don't hear any questions, so I'm moving forward. Let's talk about the severity or duration of a disease. It's another useful way of defining the scope of disease, is talking about its severity or its duration. Severity is how severe the disease is. The duration is how long it lasts. And usually, diseases are both more severe and have longer duration, or they're shorter in their duration and they're less severe. But that's not always the case. An acute disease is a disease that develops rapidly, is short-lived, and then goes away. A perfect example of an acute disease is the human cold. But another example is actually influenza. It isn't as quite as short as the cold, but it is fairly short-lived. And it is more severe than the human cold as well. This is in contrast, an acute disease, from a chronic disease. A chronic disease is where the disease develops slowly, persists for a long period of time, and the patient with time gets sicker and sicker until, of course, they get better. Mononucleosis would be a chronic disease. Hepatitis B would be a chronic disease. Another chronic disease would be leprosy, where it starts slowly and, assuming the patient isn't cured, develops slowly and gets worse with time until the patient eventually dies of leprosy. Of course, nowadays, leprosy can be cured with antibiotics. There is a term for a disease that's in between an acute disease and a chronic disease, but we're not going to cover it. It's called the subacute disease, and I don't think anyone knows sclerosing panencephalitis that is a subacute disease. So I won't hold you to that. The extent of host involvement. Infections can be classified according to the extent to which the host body is affected. Most diseases will start as a local infection, where the pathogens are limited to a small area of the body. In many diseases, will only be a local infection. An example would be a boil or an abscess, or when you get a skin disease and it's only in one portion of your skin. In fact, if it's only in your skin, that's still a local infection. However, if the disease goes further, it will become a systemic or a generalized infection, where the disease can spread throughout the body. Some diseases are systemic by nature. For example, when somebody gets the measles, it will be systemic. I think the measles is breathed in, and then it quickly spreads through the blood to the rest of the body. And the most pronounced symptom of the measles is the skin lesion, so obviously it spreads to the skin. A focal infection is a systemic infection that began as a local infection, but then spreads further. Our MRSA can be a focal infection where it starts on the skin, but then it gets into the blood and then can be spread elsewhere by the blood. Any question about any of these? If we find bacteria in the blood, we call it bacteremia, which means that there is a presence of bacteria in the blood. This is slightly different than septicemia, where there is growth of the bacteria in the blood. Now, most of the time in the clinic, they will not test to see if a patient has septicemia versus bacteremia. They will simply test to see if there's presence of bacteria in the blood. Toxemia is the presence of toxins in the blood, and viremia is the presence of viruses in the blood. Many viral diseases cause viremia, like the measles, which actually it's in the blood twice because it starts in the lungs and then spreads throughout the body by the blood, and then it's growing in different tissues and coming back to the blood. We can also talk about the extent of host involvement continuing. The state of the host resistance also determines the extent of an infection. A primary infection is an acute infection that causes the initial illness. A secondary infection is an opportunistic infection that happens after a primary infection. And usually the primary infection predisposes the patient to this secondary infection, like weakening the host immune response or weakening the host defenses, like somebody getting a respiratory infection can weaken the mucous membranes and then causing you to come down with a secondary infection. A subclinical disease is also called an asymptomatic disease, where there is no noticeable signs and symptoms. So the patient has an inapparent infection and may not know that they are infected. Some people can actually carry the polio virus but never get the polio disease, and they do not know that they have the polio virus, a subclinical disease. But that doesn't mean that they can't spread it to others. A subclinical disease has the infective agent, and they can spread that disease to other people. And the second person who gets infected may not have a subclinical disease. They can have an actual disease. And that is one reason why COVID-19 is so difficult to control. Does anybody know the number of young people who, or the percentage of young people who, when they get infected with COVID-19, they are subclinical, having no noticeable signs and symptoms? Does anybody know? Is anybody going to take a guess? Okay, I'm inviting somebody to guess. Is anybody even listening to this lecture?
Maybe 30%?
That's a good guess. It's actually closer, they think, to 50%. That 50% of young people, when they get infected with COVID-19, they actually have a subclinical disease. And then they can spread it to others. Because one thing, they don't realize they're infected. And two, other people won't know that they're infected. So I always have to laugh when I come into a building and they take my temperature, because in the first place, there are a lot of people who have COVID-19 and they have symptoms of COVID-19, but they don't have a temperature. And then young people, 50% of them will have no signs or symptoms of having COVID-19. So actually taking their temperature is not a good way to assay for whether you have COVID-19 or not. But I suppose it's just one thing they can do, so they do it. So let's talk a little bit further about the severity or duration of a disease. A latent disease is where a patient has the disease, but then the disease goes into latency or hiding, and the patient has no signs or symptoms of the disease. Most diseases, when the disease is latent, the patient cannot spread the disease. The disease, in fact, the disease agent isn't actively replicating in the patient when it is latent. A classic case of a latent disease is when usually a child gets the chicken pox, and then the chicken pox goes away, but the disease-causing organism doesn't go away. It goes into latency, and it may stay latent for decades. And then when the chickenpox virus comes out, it doesn't cause chickenpox, it causes shingles. And usually when people get chickenpox, it's during childhood. And then when they get latency, it's when they are at least middle-aged, if not elderly. There are a few diseases which frequently or always go into latency. And the best examples are some of the herpes virus, herpes simplex type 1 and 2, and then chickenpox is also a herpes virus. They go into latency. I was trying to think of another herpes virus that goes into latency, but I'm sorry, I'm not able to come into, oh, here's one. I'll bet, forgot the name of that. Is it rubiola? When we talk about viruses, I'll talk about it. It's where a child gets a rash similar to but different than the measles. And it's not rubella, so I think it's rubeola. And it turns out the children get that from their parents. And it is true that the parents have the disease as a child. In fact, human children, over 95% of the population get it. And they get it usually when they're young, within the first year or the first 2 years of life. And like I said, they get it from their parents. And the agent comes out of latency and infects the child, but the parent doesn't realize they have signs or symptoms of the disease. But they obviously, the agent came out of latency because it infected the child. And my guess is this is asymptomatic, and it comes out of latency frequently because, like I said, children tend to get that disease within their first year, and usually they get it from their parents. A herd immunity is when many immune people are in a population, and that stops the disease from spreading. Let me blow this up so I can show this to you better. When a disease hits a non-immune population like COVID-19, it then quickly spreads to other people in the population. And eventually, like with the flu, like H1N1 when it hit in 2007, the majority of the people in the population come down with it. And they will develop immunity because they got sick of H1N1 flu. You can also get immunity by getting a vaccine. Now, if enough people are immune, when somebody becomes infected, only nearby people can get the disease. There are enough people in the population that the disease can't spread because this person is immune and then this person is protected. They are not immune, but the disease can't spread from this individual to that individual. So this is herd immunity. And if enough people get vaccinated for COVID-19, the COVID-19 will stop spreading. Unfortunately, with COVID-19, we're going to need about 85% of the human population to be vaccinated before the disease will stop spreading. And that will be very difficult to achieve in the third world countries. In the first world countries, it's possible, but I'm afraid there are going to be too many people who are not going to get the vaccine that I don't think we will ever get 85% of the population immune to the vaccine. However, enough people will get the vaccine and enough people will be infected. About 20% of the population in the United States, it is believed, have been infected with COVID-19. And when you add the 20% to maybe 75% of the population are going to get vaccinated, and there will be some overlap, but that might bring the U.S. population up high enough to stop COVID-19 from spreading because of herd immunity. And that is my hope. It's possible that by this summer, enough people will be vaccinated, and with the people who have gotten COVID-19 already, that it's possible we will reach herd immunity this summer. And then the COVID-19 will have a hard time spreading. It will only spread to someone in close contact with someone who has had COVID-19. Unfortunately, after the summer goes away, COVID-19 will have an easier time spreading, so I think it will come back in the winter. But my hope is that it will largely go away in the United States in the summer because of herd immunity. Any question about any of that? We'll talk more about COVID-19 when we talk about viruses, which I think is our next lesson. All right, let's talk about the patterns that disease takes. Normally, a specific sequence of events is associated with an infection with a microbe, and many of them follow the same pattern of disease. A disease has to come from a reservoir, so a reservoir must exist where the disease comes from. The pathogen must be transmitted to a susceptible host. Like if it goes to a non-susceptible host, the patient will not be infected. An example of a non-susceptible host is someone who's immune to that disease. The pathogen, this must invade the host and must multiply in the host. And further, the pathogen must injure the host. If the pathogen does not injure the host, you will not have signs and symptoms of disease. And then the illness will end when the host immune system destroys the pathogen, or maybe when the patient takes antibiotics or some other curative disease medication, or the disease can end when the host dies. Those are the two ways the illness can end: when the host throws off disease, or when the patient dies. Any question about any of that? There are a number of predisposing factors that can make a patient more susceptible to getting a disease, and this therefore affects the occurrence of a disease. For example, females have a shorter urethra than males, so females have a higher incidence of a bladder infection. There are some inherited traits that make a patient more likely to come down with the disease, and a good example of that is sickle cell anemia gene. A sickle cell patient is more likely to come down with many other diseases because they are more susceptible. A diabetic is also more likely to come down with the disease, although a diabetic isn't really necessarily inherited. It may be inherited, it may not be. Climate and weather can predispose a patient to getting an infection. I think everybody knows that the colds and the flus are more likely to spread in the weather, and that's because the colds and the flus are more likely to survive and spread when the weather is cool or cold and the sunlight is not as intense. Fatigue can make a patient more likely to come down with disease, and I hate to tell you this, students tend to be fatigued and therefore more likely to come down with an infection. So remember to get your sleep when you can. Obviously, if you're studying or working on an assignment, that may not be possible. Age can predispose a patient to an infection, with most common diseases, both the very young and the very old are more likely to come down with an infection. That isn't true for all diseases. As you know, COVID-19 is more likely and more likely to be severe in the elderly. And the young are essentially, well, it's just less likely to be severe in the young. Lifestyle can predispose an individual to getting a disease. For example, smokers are more likely to come down with a respiratory infection than non-smokers. And then chemotherapy can predispose a patient to a disease. The main reason for that is chemotherapy weakens the host immune defense. All right, any question about these predisposing factors? No comments, so I'm going to move on. Let's talk about the development of the disease. Surprisingly, most infectious disease follow the same development of disease. Once the host defenses are breached, the disease develops following a certain sequence. And this tends to be similar for both acute and chronic diseases. When we're talking about the development of a disease, on the y-axis we have time. So initially the patient becomes infected, and then the disease develops until the disease goes away, and that happens with time. On the y-axis we have the number of infective organisms in the patient, and also along with the number of infective agents, we can also put on the y-axis the intensity of the signs and symptoms of disease. Because usually when the patient has more infective agents, they will have more severe signs and symptoms. Any question about any of that? All right. So when the patient first becomes infected, let me see if I can blow this up. When the patient first becomes infected, till the time when the patient gets signs or symptoms of disease, that is called the incubation period. When the patient has the microorganisms in them, but they have no signs or symptoms of disease. That's followed by the prodromal period, and that is when the signs or symptoms are mild. For example, when you have to think about whether you have a sore throat or not, that would be the prodromal period of disease, like a cold or the flu. When you say, geez, am I coming down with a sore throat? And you say, yes, I think I am. Prodromal period. The prodromal period begins when the incubation period ends, meaning you have signs or symptoms, and it ends when the signs or symptoms are no longer mild. The prodromal period is followed by the period of illness, and this is when the patient has the most infective agent, most infective organisms, as well as the most severe signs and symptoms. Your sore throat is no longer mild, and you don't need to think about it. You know, oh geez, I've definitely got a sore throat. Period of illness. The period of illness ends when the patient starts getting better. For example, when a patient has a fever, the period of illness ends when the fever breaks and goes away. And that is called the period of decline, where the signs and symptoms get better. The period of decline is followed by the period convalescence. This is where the infective agents get below a certain threshold number, and once they're below this threshold, the infective agents no longer give you signs or symptoms of disease. So the patient is asymptomatic, still has the infective agents, come on mouse, still have the infective agents, but they're below the threshold, so the patient has no signs or symptoms of disease. And then after convalescence, the patient is cured. They no longer have disease. Any questions about the stages of disease or the stages of disease development? All right. Now let me state that not all diseases have all the stages of disease development. For example, I've had the flu, the flu, and at one moment I'm fine, I'm in the incubation period, and the next moment it's like somebody hit me over the head with a sledgehammer. There was no prodromal period. Sometimes the flu has no prodromal period. Okay? Any questions about any of that? Another case where some of the periods are missing is some diseases never have a period of decline or a period of convalescence. That happens when the patient gets sicker and sicker and then dies. There is no period of decline and period of convalescence. AIDS used to be that way. Of course, now they have drugs that can keep the patient alive. The patient is always infected with HIV, but the patient can be kept alive for a long period of time, and so the patient may die of other causes. And let me think about that. Oftentimes with an AIDS patient, they will enter the period of illness, but then they'll go into the period of decline. I don't think they ever enter the period of convalescence, and there's very few patients, there have been a few recorded, who actually appear to have thrown off disease, but that's very few. So most AIDS patients, with the medication, they can stay in the period of decline, but they never, or most patients never throw off the disease. Any question about that? Okay, here's a question for you, and it's a question that you should try to answer because I may get nasty and ask it on a quiz. And that is, which period of disease are you not contagious? Come on. Let's have somebody guess.
Convalescence?
That is a real good guess. But in actuality, it's a trick question. If you notice here, on all of the periods of disease, you have the infective agent. So in reality, you are communicable at every period of disease, including the convalescent period. With some of the common diseases like colds and flus, at least for adults, you are most contagious late in the incubation period or in the prodromal period. This is only true for adults. The reason is that with the flu, your immune system ramps up, and so it makes you less communicable or contagious, since it's the flu, during the period of illness than during the prodromal or the late incubation period. Okay? So in all of the periods of illness, you are communicable. Now you're less communicable in the period of convalescence, and I think you're even less communicable in the period of decline than you are in the period of illness, and for the common diseases, the prodromal period and the late incubation period. Any question about any of that? So when somebody tells you, oh, I'm getting better, I'm no longer communicable, you tell them, I've taken microbiology and I know better. You are communicable. My mother always used to tell me, oh, I'm better now, I'm no longer contagious or communicable. And I'd say, Mom, I'm a microbiology instructor. I know better. All right, any question about the periods of disease development? It is a fascinating topic. Let's move on, if there's no questions, to the spread of an infection. Disease has to come from a reservoir, a source of the infection. Reservoirs of infection are continual sources of the disease organism. Reservoirs can be living or non-living, depending on the disease. Obviously, some reservoirs have to be living. For example, AIDS only comes from other humans, as well as gonorrhea. So the reservoir has to be a living reservoir. And in fact, it has to be a human reservoir. Humans are very good reservoirs for human diseases. And some diseases have to come from only humans. Like I think measles has to come only from other humans. Some diseases, though, can come from humans or other animals, like the flu, as well as certain colds, can come from other animals. And usually the flu comes from horses or pigs or birds. But occasionally you can get these diseases from other animals, like your cats and your dogs. Fortunately, cats and the dogs, for some reason, are less likely to spread and less likely to get colds and flus from humans as well as give it to humans. But they can get colds and flus. Not often, but they can. For some reason, at least with the flu, it tends to come from horses or pigs or birds. And if you think about it, birds are very much different from us, and I would think that cats and dogs are much closer to us, but we are more likely to get the flu from birds than we are from cats and dogs. Some diseases can come from animal reservoirs. Some diseases only come from animal reservoirs. A classic example is rabies and Lyme disease. We only get these from an animal reservoir. If you don't know, when a human gets rabies, it's a dead end. The disease cannot spread from a human. So rabies has to come from an animal, and it spreads from other animals to humans. But rabies cannot spread from a human to other humans or other animals. I believe Lyme disease can spread from humans. Zoonoses are diseases that are transmitted from animals to humans. So zoonoses are animal diseases that are transmitted to humans. And rabies is a zoonoses. Any question about any of that? All right? Some reservoirs are non-living. For example, botulism and tetanus, to my knowledge, always come from a non-living reservoir. Botulism, usually from food products, like canned food products. Tetanus, usually from the soil or by stepping on a nail or something like that. But many cases of humans get diseases from non-living reservoirs, like when we pick up disease from the soil, the water, or lettuce. For example, probably most human E. coli infections are picked up from lettuce or some other food product that we eat, and that is considered a non-living reservoir. The lettuce was once alive, but they're counting it as non-living once it's been picked. Okay, any question about any of that? If not, let's move on to the transmission of disease. There are three principal routes by which a causative agent of disease can be transmitted from the reservoir of infection to a susceptible host. Let's put that over here. There can be contact transmission, where disease is directly spread to another individual by direct contact. Contact transmission. There's also vehicle transmission, where some object spreads the disease from one person or a reservoir to a healthy person who then comes down by disease, like from the food or the glass. That's opposed to vector transmission, where disease is spread to a human by an animal. And a classic example of that is when rabies is spread from an animal to a human. But an animal can also spread disease from an infected person to a healthy individual. And I'm trying to think of a good case of that. Obviously, malaria grows in human and is picked up by a mosquito, which then can spread it to another healthy individual. The complication is that malaria also grows in the mosquito. But still, malaria is transmitted by a vector. So a vehicle is an object spreading the agent to a healthy individual. A vector is an animal spreading the agent to a healthy individual. So there are three types of contact transmission where disease spreads from contact. There's direct person-to-person transmission, requires close association between an infected individual and a susceptible individual. An example of direct contact transmission would be when you pick it up from shaking somebody's hand like when they have the flu and you shake their hand and then you pick it up. In actuality, we'll talk a little bit more about this. With the flu, the majority of individuals actually pick it up on their hands first, the agent that causes the flu, and then the individual inoculates one of the mucous membranes in their face. So the majority of the flu is spread by, well, either direct person to person contact transmission or indirect contact transmission, like when somebody, I don't know, coughs on a pencil or touches this pencil, and then somebody else touches this pencil, and that's indirect contact transmission, where the disease is spread from the reservoir to an object, and we call that object a fomite. And then the individual picks it up on their hands, and then if it's the flu, inoculates one of the mucous membranes of their face. Another example of indirect transmission is where contaminated money, or a baseball, which I'll show you in a little bit, spreads the disease from one patient to another. Any question about indirect transmission? Droplet transmission is transmission via an airborne droplet that travels less than 1 meter. This is different than airborne transmission, which I'll talk about later. Airborne transmission is where it travels more than 1 meter. So here we have direct transmission from one patient to another. Airborne droplet transmission, where somebody sneezes or coughs, and from 1 meter, that's defined as droplet transmission. Oops, didn't mean to do that. After 1 meter, it's no longer droplet transmission. And then indirect transmission, where the baseball spreads disease from one patient to another patient. So droplet transmission is from 1 meter from the patient, so about to here. And then after that is airborne transmission, which is not contact transmission. It is vehicle transmission, which is where I am never going to test you on the difference between airborne transmission and droplet transmission, because personally I think this is a little bit arbitrary. After 1 meter it's airborne, before 1 meter it's droplet, and it comes from the same sneeze. So I just think that's a little bit too arbitrary, and so I won't be holding you for knowing the difference between those two and knowing the difference. But actually airborne transmission is considered a vehicle transmission. Other vehicle transmission is where an inanimate reservoir spreads the disease, meaning something like food, water, body fluids, or an object can transmit the agent from one individual to another individual. A waterborne transmission is where the water transmits the agent, like contamination by sewage. Gosh, what is that disease that actually prefers to be? I'm drawing a blank here. It's very rare in the United States, but in third world countries, there's a bacteria that spreads by the water. And boy, I'm drawing a blank on what the heck the name of that disease is. Anyways, waterborne transmission, contamination of the water. When Americans go to Mexico and they get Montezuma's revenge, that's waterborne transmission. Foodborne transmission is another vehicle transmission when the food has been poorly handled or unsanitarily handled or improperly stored, and then the food brings the disease to you. Usually when you go to a restaurant, you are unlikely to get disease from the food, assuming the food is cooked, because the cooking destroys the infective agent. However, other foods which are not cooked, as well as the utensils or the plate, are handled by the server, and you can get disease that way. But usually the food is fairly safe if it's cooked. Airborne transmission, as I mentioned, is where the droplet travels more than 1 meter from one host to another. And that also is vehicle transmission. Vector transmission is where an animal carries the pathogen to a host. The most important group of vectors are the arthropods, especially biting fleas, ticks, and mosquitoes. They pick up the disease, usually from their biting a patient, and then spreading it to the next patient they bite. Disease can be transmitted by mechanical transmission, and this is passive, like the fly picks up the disease-causing agent, and then the fly deposited on the food, and then the food is consumed, and the individual picks up the disease agent by mechanical transmission, passive transport on the feet or other body parts of the fly or some other animal. Any question about that? That differs from biological transmission, where the pathogen reproduces inside the vector, and then the vector spreads the disease to the patient. A classic example of biological transmission is where malaria infects a mosquito, grows inside the mosquito, and then the mosquito bites the patient, spreading the malaria to the patient by biological transmission. Any question about vector transmission? If not, let's talk about nosocomial infections. These are also called hospital-acquired infections, where a patient gets an infection from their stay in a hospital or other healthcare facility. So they would not have gotten the nosocomial infection if they had not gone to the hospital or the hospital-like healthcare setting. Nosocomial infections is one of the most important topics you can learn in microbiology, because many of you are going to be working, if not all of you, in a hospital or healthcare facility, and you need to know how to prevent the spread of nosocomial infections. Nosocomial infections are a problem in the hospital or healthcare setting, and we need to know how to prevent them. We can't get rid of them, but we can reduce their numbers. Nosocomial infections happen as a result of staying in a hospital or hospital healthcare facility, and the patient would not have gotten them if they had not gone to that healthcare facility. It's estimated that about 5 to 15% of all hospital patients come down with a nosocomial infection. This is about 2 million people per year in the United States, or about 20,000 deaths in the United States because the patient came down with a nosocomial infection. It is the 8th leading cause of death in the United States, or at least it used to be. Nosocomial infections have been decreasing, I'm happy to say, since the textbook was written. So now they are getting closer to 5%. But your textbook isn't going to say that because, like I said, this is something only recent in the last couple of years, not more than a few years, where the nosocomial infective agents have been reduced down to about 5%. So the CDC says that over 1 in 20 hospital patients gets a nosocomial infection. Then about 50% of nosocomial infections are preventable. They have a huge cost. You don't need to know any of the numbers or even what the cost is, but I'm just putting them on the slide here. Nosocomial infections result from the interaction of 3 factors that happen in a healthcare environment. First, the microorganisms are present in the hospital or the healthcare facility. It's unavoidable. You will always have microorganisms which can cause a nosocomial infection. But hospitals are a major reservoir of sick patients, and sick patients have the nosocomial infective agents. Okay? So hospitals are a major reservoir of nosocomial infective agents. And you have to make sure that that agent doesn't spread from one patient to another. Some normal microbiota can be nosocomial infective agents as an opportunistic pathogen. And then some nosocomial pathogens are antibiotic resistant, and that makes them a very serious disease for a hospital patient to get. Any question about the first reason why we have nosocomial infections? And that is simply microorganisms will always be in the hospital, and then hospitals are major reservoirs of nosocomial infective agents. The second reason why hospitals have nosocomial infection is many of the patients in the hospital are compromised hosts, one whose resistance to infection is impaired either by disease, by therapy, by burns, or to some other, what am I trying to say? Some other agent that weakens the host immune system. Broken skin what am I saying? Trauma is what I'm trying to say. Burns or trauma. Broken skin, broken mucous membranes can make the host compromised and more likely to get infection. Burns do the same thing. Burned skin is more likely to get infected than healthy skin. Injections can make the patient more likely to get a nosocomial infection. Ventilators, urinary catheters, even the administration of anesthesia makes the patient more susceptible to getting a nosocomial infection. Some patients have a suppressed immune system in the hospital. These will be patients taking certain drugs, taking radiation therapy, and then burn patients. And they're going to be more likely to get a nosocomial infection. And then there's a chain of transmission in the hospital or the healthcare facility. The principal routes of transmission are direct contact transmission, such as patient to patient, or patient to hospital worker to patient. So when a special care units, the hospital staff needs to make sure they don't spread the nosocomial infective agent from one patient to another. There can be indirect contact transmission via a fomite, like when a urinary or IV catheter spreads a nosocomial infection, or when contaminated surgical dressing spreads a nosocomial infection to a patient. It could be something as simple as somebody touching the doorknob, indirect contact transmission, and then the patient decides to go walking in the hallway, and then they touch the doorknob. And then there can be vehicle or airborne transmission, which is spread by the ventilation system. Fortunately, in the hospital, vehicle transmission is rare, but there are some diseases, like in the child's ward, like measles, COVID-19, where the disease could spread by the ventilation system. Any question about the chain of transmission of a nosocomial infection? All right, there are procedures to control nosocomial infections, and if you work in a healthcare facility, you should learn these procedures. So certain procedures are generally implemented to prevent nosocomial infections. First, always use the aseptic technique. Always, when you're in the hospital. You've learned it in microbiology. When you start work, use it. Use proper handling of contaminated materials so that you don't spread a nosocomial infection. And another thing that prevents the spread of nosocomial infection is frequent and thorough hand washing. It also helps to educate the staff, the patient, and the visitors. The hospitals have gotten, at least in the United States, very good about educating even the visitors as well as the patients and, of course, the staff. Like in almost all hospitals, there's a sign on the elevator and by the door telling you to use hand sanitizer. And with that done, that has reduced the spread of nosocomial infections. There are many other procedures you can use to reduce the spread of nosocomial infections, and I'm going to suggest take a look at the online chapter notes as they discuss some of these procedures. Any question about nosocomial infections? If not, let me end here and say that if you simply wash your hands after every patient, you can reduce the spread of nosocomial infection by about 50%. So always wash your hands in between patients. All right, if there's no questions, I'm going to end it here. And if you have questions in the lab, I'll be there from 6:30 to 6:45. All right. Goodbye.